Oh, just in time when the test is over. Were you waiting outside the door? Were you hiding around the corner? Okay, so I've just started functions. This is book 5, chapter 8. Okay, and as per usual, I'm going to sum up all the junior cert stuff in about 5 minutes. Okay, right. So a function was, right, you take an input, you put it into the function, so the function is a rule. So the rule might be square it and add 4. It might be take away 5 of it, right, okay, and you get an output, right? You put in an x, you get out a y. Now it's only a function for which each x value gives you a unique y value. So that means for any input you put in, the answer you get out has to be unique. As in, if you put in a 2, you get out a 10. You can't put in a 2 again and get out a 15, right? So for every x, there's only one y, okay? So you can't have more than one answer. So if you put in a 2, you can only get out one number, right? If you put in a 5, you can only get out one number to go with the 5. If you get out more than one number, right, it's not a function, okay? And we'll see in a minute, right, how you decide whether something is a function or not. Right, and functions can be represented by a list of ordered pairs or couples, right? So for example, right, here's a function. 1, I put in a 2, I put in a 1, I got out a 2. I put in a 2 and got out a 4. I put in a 3, get out a 6. Now I don't have a rule at the moment, right? I put in a 4 and got out an 8, and that'll do me. That's a function, right? So input, output, right? Okay, and we're used to graphing those points, aren't we? Right? So that's what we'll eventually be getting to, graphing these points, okay? Right? So put in a 1, get out a 2, put in a 2, get out a 4, etc. Please note, right, there is no extra one there. I didn't put in a 2 and get out a different number, okay? Because if you put in a 2, you're only allowed to get out one unique number, okay? So one unique number for whatever input you put in, right? Did you win your match? I never asked you. No, right. I pretend I never asked, so. Who were you playing? Oh, that's even worse. Sorry? Oh, right, okay. I have children that go to Crescent Comp, so I just hope they don't hear that they beat Laurel Hill, because they'll go on and on and on. That's recorded now on YouTube, but it's okay. They'll never watch my videos, especially about maths. I know that. Right? Okay. Can I go? Right? Are we okay? So a function can be represented by a list of ordered couples, or it can be represented by a mapping diagram, right? So mapping diagrams, right? Remember we had these in junior cert. There, I'll only do 3 here because I have to make it really small. So 1, 2, because I didn't leave enough room. 4, 6. Now I know you can't read that, so I'll call it out here. So 1 goes to 2, 2 goes to 4, and 3 goes to 6. Okay, is that all right? Right? Or it can be represented by a graph, right? So I don't know what function you come out with, but you might end up with a smiley face. You might end up with a straight line. You might end up with a curve. Who knows, right? You could end up with anything, but you can represent a function on a graph. So you can look at a graph and say that's a function. Okay? Then I need to talk about the domain, the range, and the codomain. Right? Okay? So the domain is a set of all the inputs. So from that mapping diagram, the domain would be 1, 2, and 3. Everything you put in. Right? Okay? The range is all the actual outputs. So everything, all the outputs that are actually have arrows coming into them. Okay? So 2, 4, and 6 above. Okay? I'll explain more about the actual outputs and the possible outputs in a minute, so don't stress about that just yet. Actual outputs, there might be numbers in that are, oh my god, there might be numbers that are actually possibly, could be a possible outcome, but they just didn't happen to get picked, right? So they could have been picked for the team, but maybe they just didn't get picked. So 2, 4, 6, and 8 will be the codomain above. I will talk more about that in a minute. Okay, I'll talk more about codomain in a minute and domain and range. But for the moment, the domain is what you put in, the range is what you get out, and the codomain is all the possibilities that you could get out. Okay, so they mightn't actually come out, but it's possible to get them. Okay. Right, are we good? Right, okay. So before I go any further, I need to remind you what N stands for, what Z stands for, what R stands for, what Q stands for, and what R less Q stands for. So N is natural numbers. You all remember what the natural numbers are, don't you? Counting numbers, positive whole numbers. So start out counting numbers, sometimes they call them, okay? They're the positive whole numbers, so it's starting at 1, 2, 3, all the way up. No negative numbers. 0 is not a natural number, right? Because when you're counting, you don't start at 0, you start at 1, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. I got tired there, right? Z are the integers. You know what integers are. Tell me what integers are. Positive and negative whole numbers. So positive and negative.
Excuse me, please. Would Paige Nash and Jennifer Fitzpatrick come to reception at the bell, please? Thank you.
Positive and negative whole numbers. So, and naught is an integer. Okay? So it goes 0, 1, 2, 3, 4, 5, 6 on forever, but it also goes -1, -2, -3 down forever. So it goes up forever, down forever. And naught is an integer. Naught is not a natural number, but it is an integer. R is real numbers, which is absolutely everything. Positive, negative, fractions, decimals, everything. Square roots, decimals that go on forever. Real numbers is absolutely everything. So everything is a real number, right? Everything is a real number, right? Rational numbers can be written as a fraction. So most numbers are rational, as in 4 can be written as 4/1. 0.333333 recurring can be written as a third. I think I left out the C in fraction there. Okay, sorry. So can be written as a fraction. That does not look like fraction, but you know that says fraction, okay, even though it doesn't look like it. Is that all right? Okay. And irrational numbers cannot be written as a fraction. Or less q. You know the set sign, or less q. You remember in sets, I know I'm probably going back to second year now, right? Or less q. It means start with all of r and take out all the fractions. So if you have everything and you take out everything that can be written as a fraction, you get what's left, which is any numbers that cannot be written as a fraction. And they are decimals that go on forever. So you can't write decimals as decimals that go on forever as a fraction. For example, pi. Unless they're recurring decimals, unless there's a pattern. If there's a pattern, you can write them as a fraction. But if it's just like pi, 3.14159, blah, 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 and it goes on forever. Okay? Right, and it's all different. There's no pattern. It's just random numbers. Right? Okay, pi is irrational. Square root of 2 is irrational. Right? Square root of 2 cannot be written as a fraction. It's a big long decimal that goes on forever. So if you have a calculator that shows 10 places of decimals, it'll give you 10 places of decimals. If you had a calculator that showed 30 places of decimals, there'll be 30 places of decimals. Is that okay? So it goes on forever, right? Something like the square root of 7 is also irrational. It goes on forever, etc. They're just examples of irrational numbers. So that's just me reminding you of all the jargon. Something, yes?
Would another irrational number be, do you know, the 3.14, like the E that you do in lots?
Yeah, E is 2 points. Yeah, E is an irrational number. Yeah, very good. E is an irrational number. That's just a constant that comes up in maths as well, right? And it's an irrational number. You can't write it as a fraction. It's a big long decimal, right? Okay, are we good? Right, so they're not, I haven't used them to do anything yet. I'm just kind of throwing out words that are going to come up at you. Okay, right, are we good? Can I move on? Right, so when we see a function, right, for leaving cert there's going to be an extra bit added in, right? Okay, when we did junior cert, it would be something like f of x will give me x squared. Something like that, wouldn't it? Do you remember that? Sometimes they go f colon x equals x squared or something like that, yeah? Okay, do you remember those from junior cert? And remember we use graph them, right? We'll be graphing them in this as well, okay? Right, there's an extra bit. This is n goes to n, right? Okay, so everything that this means, f is just the name of the function. Sometimes they call it f, they normally call him f, they can call him g, they can call it h, they can call it Amy, they can call it anything they want to call it, okay? This is the domain, right? So the domain is everything I'm allowed put in, right? So here I'm allowed put in any natural number, right? This is the range, right? It's actually the codomain. Sorry, notation. Notation, sorry. Okay. I forget people have to read this. I was getting carried away while you were doing your test. I was delighted with myself. Right. Okay, so that says notation. Right, so this is what, when the function comes up, this is the way it's going to look. Right? In junior cert, we would have had just f of x is x squared. Right, but now there's going to be a little extra bit in here. And the extra bit gives you the domain and the codomain. So the domain is all the numbers you can put in. Right, okay, so in this function, I can put in any natural number. Okay, so I can put in 1, 2, 3, 4, 5, 6, 100. I can put in any natural number. I'm not allowed to put in -1 because it's not a natural number. Okay? all my codomain, all the possibilities, anything that comes out is also going to be a natural number, right? So anything that comes out is also going to be a natural number. Not all natural numbers will come out. If it was a range, they're the ones that actually come out, but the codomain is the possible ones that come out. So this just tells me that any natural number is a possibility, right? Is that okay? Right, and this is the input, as in you put in x, we always put in x, and this is the rule, right, and the rule will lead to the output. So this is the rule, and the rule will lead to the output, agreed? Right, okay, so just to go back to my explanation of domain, range and codomain there a minute ago, right? The domain is everything you're allowed to put in. So what am I going to put in? I'm going to put in all the natural numbers, aren't I? Okay. The range is what actually comes out. So if I put in a 1, I'll get out a 1. If I put in a 2, what'll I get out? 4. If I put in a 3, what'll I get out? 9. If I put in a 4, what'll I get out? And so on. So basically the range is all the square numbers. 1, 4, 9, 16, 25, 36 and so on. And dot dot dot, it goes on further. Okay, so it's all the square numbers. So they're the ones that actually come out. Right? The codomain is all the possibilities. This is the codomain. So basically any natural number is possible. Okay? According to that rule, any natural number is possible. Okay? Right. Say that again? N is also N. Right? So that's the codomain. This is the domain. The range is the actual ones that come out. Like, because 5 is never going to come out because it's not anything squared. 7 is not going to come out because nothing squared will give you 7. Do you know what I mean? Okay? So the range is what actually comes out. The codomain is the possibilities. Okay? Here is another function. Right? F is the name. What's R? What's this R? The domain. What you're allowed to put in. So I'm allowed to put in any real number. Right? What's this R? This R is a codomain. So any real number can come out. Right? Okay? And the rule is, right, okay, you put in an x and you get out an x squared plus 2. So whatever you put in, you square it and you add 2 to the answer. So you're allowed to put in any real number. So if you put in any, the range is also real, all the R's, because there's no specific ones. Because I can put in 1.29743 and get out an answer. I can put in minus 3.47194 and get out an answer. So all the range and the codomain are actually the same here, because any real number is possible. Okay?
Wait, miss.
Yes.
Why would the codomain have like minus numbers if it's squared? Oh,
It actually wouldn't, sure, you're right.
yeah.
You are right. That's a really good, now it's possible, but
Oh, yeah.
the actual range, this is what I made a mistake there. The range should only be what? R with a positive sign on it means I'll only get out what? Positive real numbers. See the R with a positive sign on it. That means you'll only get positive real numbers, which Carolina just told me, right? Okay, she said you can put in any real number, but you'd only get out positive real numbers, wouldn't you? Because whatever you put in, you square it, that's positive, and you add on 2, it's still positive, isn't it? So that's positive real numbers, which I was going to explain in the next example, but now I just explain it here. Right? Okay. Sorry? Yeah, sorry. What I did was I magnified it and then now it doesn't fit in. Right, okay. Right, are we good? The last one is, right, where I was going to explain what R positive means. Right, so F is the name of the function. R positive means you're only allowed to put in positive real numbers. right? And the reason for this is because the function is ln x, log to the base e of x, and you can't get the log of a negative number. So if you try to put in negative numbers, the log of a negative number doesn't exist, so it's not a function, right? So you're only allowed to put in positive numbers. See that real, you can put in any real number, which is any fraction, decimal, whole number, etc., but it has to be positive. So that's what R plus means. It has to be positive. So the domain is R plus, right? The range is, the codomain is R, and the range is also R. As in, you can't make a list of all the outputs, right? Because there's so many, every number is possible. Okay, is that all right? So that's just the notation, because when the questions come up, right, this is what you'll be, this is what it will look like. And from the notation, you should be able to pick out the domain, the range, and the codomain. Is that all right? Okay, right. How do you look at something and say it's a function, right? So that's our next plan, right? Can I go? Yeah? Okay, so our next plan is, how do you test for a function? How do you look at a list and say it's a function? How do you look at a mapping diagram and decide whether it's a function or not? How do you look at a graph and decide it's a function or not? So from a list, okay, so I had a list there a while ago, 1, 2, 2, 4, right, 3, 6, and 4, 8. That is a function, right? It is a function, and how you know from a list whether something is a function or not, no first number, no input is repeated. No input is repeated. And you know the input is the first number. So no input is repeated. So 1, 2, 2, 4, 1 is only there as a first number. Doesn't matter about the second number. Doesn't matter, the second number can be repeated every time. I could have 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, etc. Right, the second number can repeat it as much as you like, but the first number cannot be repeated. Is that okay? So in order for it to be a function, the no input is repeated. The first number is never repeated. That's how you know from a list it's a function or not, right? From a mapping diagram, girls, okay, and I won't bother putting any numbers in, but from a mapping diagram, right, okay, so from a mapping diagram, you have exactly one arrow, so that means exactly one, not more than one, not less than one. Exactly one arrow leaving the first circle. Again, it doesn't actually matter where they go, right, as long as there's only one arrow leaving each input value in the first circle. So there's only one arrow, there's exactly one. Not 0, not 2, right, okay, exactly 1. So if I put in an extra dot there, that is not, that's immediately made that not a function. Is that all right? If I have, I'm going to take that out again. If I have a second arrow leaving, right, okay, there's 2 arrows leaving the first dot, that makes it not a function. Is that okay? So again, I'm going to take that out because I want it to be a function. Right? Are we good? Exactly one arrow leaving the first circle. I should exactly one arrow leaving every point in the first circle, but you get it. Right? Okay. And from a graph, girls, from a graph, you do the vertical line test. So if I tell you, I give you a graph and I say, is this a function? Here's a graph. Is this a function? What you do is the vertical line test. So you draw a vertical line anywhere. And the vertical line must hit exactly once. So vertical line must hit exactly once. So when you draw a vertical line on a graph, so this is how you tell whether something is a function or not by looking at a graph. So you look at this one. Is this a function? Enter? No. 2 reasons. This vertical line hits it twice, doesn't it? And this vertical line doesn't hit it at all. So that's not a function. Right? Okay. Is this a function? Is that a function? Yeah. Doesn't matter where you draw the vertical line. So this is not a function. And this is a function, because it doesn't matter where you draw the vertical line, it's going to hit it exactly once, isn't it? Draw a vertical line anywhere at all, right? So you can draw the vertical line anywhere. If it hits it more than once or not at all, it's not a function. And if it hits it exactly once, it is a function. Does that make sense to everyone? Okay, so that's how you tell something is a function. From a list, you look at the first numbers, see how they repeat it. From a mapping diagram, you have exactly 1 arrow leaving all the first circle. Okay, so not 2, not 0, right? And from a graph, how do you tell whether something is a function? You use the vertical line test, and if it hits the graph, it must hit the graph exactly once. So if it hits it twice, as it did here, it's not a function. If you can draw a vertical line that never hits the graph, that's also not a function. Okay, is that all right? Are we good? Right, okay. Finally, right, okay, this is the last thing, I promise. I know I'll be worked to the bone. Right, okay, finally, this came up, you know, when we were drawing graphs, just a different way you can write these. You know, when we were doing the, what you call them, solving the quadratic inequalities. And remember, we ended up with a kind of a, this was the answer. Right, there's another way of writing this, okay? And I got it in the test, so somebody obviously did it with their grinds teacher, and that's perfectly fine. Okay, but you see, I would have given you full marks, and this is why. So, you didn't know it up to now, but you know it now. See this? X is between A and B, agreed? Are A and B part of the answer? Is A part of the answer? Yeah, so you do a square bracket around A to say A is included. And B, is B included? Yeah, so B is also part of the answer, so you do a square bracket again. Okay, this one, is A included? No, because it's greater than A, it's not greater than or equal to A, agreed? So how you show that is A with a roundy bracket. Is B included? Yeah, so you put B, but you put a square bracket on it. So that says A is not included, so a roundy bracket says it's not included, a square bracket says it is included. What about this one? Is A included? Yeah, so you put a square bracket around A. Is B included? No, so a roundy bracket around B. Is that okay? This one, A included? No. Is B included? No. So a roundy bracket around A and a roundy bracket around B. So that means the answers are between A and B, but A and B themselves are not included. Okay? Right? This one, X is greater than A, right, is greater than or equal to A. So is A included? Yeah, so square bracket around A, and it goes on forever, doesn't it? It's greater than A, so it goes forever. So you can write infinity. So, you know, infinity symbol, 8 on its side. Oh, for God's sake, I was supposed to improve on it. And 8 on its side. And girls, you always put a roundy bracket around infinity, because infinity goes forever, right? And you think you're at the end and you can go one step further, okay? So it's never ending, so there's a roundy bracket, okay? And this one, is A is not included, so that means you start with a rounded bracket and it goes to infinity, and as I say, infinity always gets a rounded bracket. Is that good? Right, okay. I think that's all I have to say today. It was really about notation and, you know, how you see the questions. So I'm going to get you to do page 235 to 236. I haven't done any of question 5, but I'm going to give it to you to see do you remember it. Okay, so just 1 to 5. It's not very long at all, but you did a test today, so you deserve a break. Okay, is that alright?